Here we are asked to determine which of the following functions are power functions. So we have to know what we mean by a power function first. A power function is a product of a coefficient, a real number, and a variable raised to a fixed real number. All right, so it's the product of a real number and a variable raised to a fixed real number. That is a power function, and it will be just a single term. And so we want to identify from these which of these are power functions. And we're going to have to manipulate some of these to make sure we can see if they are power functions or not. The first one, we have the function 1, right? The function is equal to 1. It's a constant function. But I could write this as 1x to the 0 power. Because recall that x to the 0 power, any non-zero number to the 0 power is 1. And so I've written this in a form to where it is now a power function, 1x to the 0. So this is a power function. Our second example, we have the function 7x. Well, x, remembering our rules for exponents, any variable is the same as the variable raised to the first power. So 7x to the first is the same as 7x. And now again, now I have a product of a real number, 7, and a variable, x, raised to the fixed real number, 1. This is a power function. The next example, the function negative 3x squared, is more straightforward. We have a real number, negative 3, a variable raised to a fixed power. Variable is x raised to a fixed power 2. This is a power function. Similarly, 6x cubed is also a power function. About 4 over x. All right, so this one's a little tougher, but if you remember your rules for exponents, this is the same as writing 4 times x to the negative first power. And so I have a coefficient, a constant, right, a real number, 4, a variable, x, raised to a fixed real number, negative 1. This is a power function. Similarly, in the next example, I have negative 9 over x squared. That's the same as negative 9x to the negative second power. And again, using similar reasoning as the previous exercise, this is a power function. The next example, we have 6 times the square root of x. Again, if you remember some properties of exponents, the square root, since the index on that radical is a 2, though we normally don't write it, this is the same as writing 6 times x to the 1/2 power. And again, I have a constant, a real number, 6, times the variable x raised to a fixed real number, 1/2. This is a power function. Similarly, the next example, here I have a cube root of x. That's the same as writing some negative 12x to the 1/3 power. And again, this is a power function. You say, well, gosh, is everything a power function? Well, this next example is not a power function. The absolute value cannot be written as a power. The absolute value of x, I cannot write absolute value of x as x to a fixed power. This is not a power function. Some other examples that are non-power functions. Transformations of some of these other functions that were power functions. So like that 6 times the square root of x, that's a power function. But if I write, say, g of x and call it 6 times the square root of x minus 5, this is not a power function because that's 6 times x minus 5 to the 1/2 power, but that's not a power, it's not just x to the power. Another example that is not a power function is what we'll learn about in a couple functions we'll learn about usually later on in your course of study, exponential functions. So if I had a function like this, 7 times 2 to the x power, this is an exponential function. It is not a power function because we need a variable raised to a fixed real number. Here I have a fixed number, 2, raised to a variable. That's not a power function. We'll call that an exponential function. Another function related to the exponential functions, those are logarithmic functions. They're inverses of the exponential function. So I hope this gives you an idea of how to find a power function and a few examples of functions that are not power functions.